Okay, exercise 3A, Cambridge, some solutions. Question 16B. This again is radians. Simplify sine pi on 2 minus x. You recognize that as sine what? 90 minus x is just? Anyone? Good, that one's okay. Let's just look at 16D. I'll just do one more. Cos of pi plus x. Cos of pi plus x. Cos of pi plus x, that's like cos of 180 plus theta. We're in quadrant 3. All stations to central. Negative cos of that acute angle. Yes? 180 plus theta, quadrant 3. So cos is negative in quadrant 3, so that's negative cos x. Okay, question 17. Find the exact value of, I'll go to question C, tan, I think it says 29 pi on 6. Find the exact value of tan 29 pi on 6. Oh. This is tan of almost 5 pi, because 30 on 6 is 5. I want to be working from 0 to 2 pi. So remember, every revolution, once you've gone 360 degrees or 2 pi, see, look, 0, 2 pi. Another 2 pi gives me 4 pi. This is actually over here, somewhere there. Because that's 5 pi here. Look, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi is here. It's actually over here. But what you can do, why don't you just keep subtracting 2 pi and 2 pi from it? So just get your fraction 29 over 6. Take away 2. Take away 2. Do you know why I'm taking away 2? So I want to go like this. 29 pi over 6. But of course you can't put the pi in your calculator. Minus 2 pi. Minus 2 pi. But do not put the 2's in. So 29 over 6 minus 2 gives you, yeah, so basically, sorry, I should put tan of that, which is tan of 5 pi on 6. Now we can answer the question. All right, where's 5 pi on 6? It's there. If that's 5 pi on 6, what's this little thing in here? Good. So that is all stations to central. See, whenever tan, sine, cos, tan are bigger than 90 degrees, you must change them into an acute angle and put a positive or negative in front. What do we got? Negative. Tan of the acute angle. Because there's your, yep, negative tan. Would that be 30? Tan 30 is the little one. Little, yep, negative 1 on root 3. Right. Keep going. Just another question from question 17. It's to find the exact value of cosec 3 pi on 2. Now, isn't cosec 1 over? 1 over what? Sine. 1 over sine 3 pi on 2. This is sine 1 over sine 3 pi on 2. You've got to recognize your radian measures for 90, 180, 270, 360. 90 degrees is pi on 2. 180 degrees is pi, remember? So pi is 180. Pi on 2 is 90. 3 lots of pi on 2 is 270. You have to know what is 270. I'm just going to sketch the cos curve. The other thing is, sorry, the sine curve. Here's the sine curve. Instead of writing 360 here now, we write 2 pi, pi. Obviously 1.5 pi is there. Got it? So what's sine of 270? Or 3 pi and 2? Negative 1. So it's negative 1. Okay? So girls, if you're ever asked for sine 0, 90, 180, 270, 360, sketch the graph. Don't go and use other methods. If you're asked for the cos of the same, cos of 0, 90, 180, 270, 360, sketch the graph. Read it off the graph. Okay? All right. So question 18a, solve for x from 0 to 2 pi. Now, I know this is root 2 minus 1, but that's just a number, girls. So this is just tan of x is something, okay? Now, so you'll just work out what the acute, which, root 2, what's root 2 approximately equal to? Work out what root 2 minus 1 is. Girls, square root of 2. No one knows it?
0.4.
Yeah, so the answer, yeah, is 1.4. 1.4 minus 1 is 0.4, roughly. In other words, is it positive? Yeah. So tan of x, I'm just going to go here, is positive in quadrants 1 and 3. But I want my acute angle, x. You would just go tan to the minus 1 of root 2 minus 1. Now, I know they want this in radians, but just find it in degrees first. 22.5 degrees. Now we're going to convert that to radians. Now, what's 45 degrees? Pi on what? So what do you think half of that is? Half of 40, pi on 8. So if 45 degrees is pi on 4, how do we know this? If you've got a circle and you've got a quarter and you cut them into smaller pieces, you've got 8 when you halve your quarters. So that's pi on 8. Because 45 degrees is pi on 4, half of 45 is 22.5 degrees, half of a quarter is an 8, pi on 8. If worse comes to worse, girls, you would just go on your calculator, 22.5, you don't put the pi in, do you? You go 22.5 ABC 180, 22.5, if you want to change it to radians, you go 22.5 times pi over 180, the 22.5 over 180 is 1/8. All right, so 22.5 degrees is pi on 8. So what are my solutions? X is quadrant 1 and 3. Draw it. Much better to draw it. What is it? Pi on 8 is quadrant 1. Come on, 0. Pi plus pi on 8, which is basically 1 and 1/8. 9 pi on 8. Okay, that's that one. So don't... All right, this question. If it was just 3 sine x equals cos x, what would you do? What's the rule? What do sine and cos? Tan. So you divide both sides by cos squared x, or you can put that over there. You can put that under there and put this. Yeah? So, look, you can just divide both sides. I'd be dividing by 3 cos squared x. What? All right.
Cos squared x equals 1 minus sin squared x.
Yeah, we can do that, actually. Yeah, there's a lot of different ways we can do this. We can do this lots of different ways, and I'm happy to do it a few different ways, actually. We can't, so let's do that, actually. 3 sine squared x is 1 minus sine squared x. That's actually a good idea. We're going to do it this way. So what have I got? 3 sine squared x, what? Plus sine squared x equals, oh no, minus 1 equals 0. Actually, why didn't I just leave the 1 there? I'm going to take it back. But it doesn't matter. What's this?
4 sine squared x.
So 4 sine squared x, I'm taking the 1 back over, equals 1. Do you know what I'm doing now? Sine squared x is a quarter. Are we good? Sine of x equals plus or minus, yeah, the square root of that, which is, no roots. Square root of 4 is just 2. Plus or minus a half. I'm going to try this the tan way in a minute, all right? So what have we got? All 4 quadrants. I just hope I haven't.
But why is it all 4?
Because it's plus or minus.
Oh,
So if it's plus a half, it's quadrants 1 and 2. If it's minus a half, it's quadrants 3 and 4. Whenever you've got tan, x is something, plus or minus, cos x is plus or minus, sin x is plus or minus, we're talking about all the positive and the negative quadrants. It's all 4. So whenever you've got squared, see, because we're trying to find x, so you need to square root here. Remember when you square root, you take plus or minus of the other side. So this is all 4 quadrants. Where's sign positive, where's it negative? It's only positive or negative, so it covers all four. What's the acute angle? Yeah, it's 30, which is pi on 6. So therefore your solutions are from 0 to... Actually, have you already done your solutions?
Yeah.
All right. So what are they?
Pi on 6.
Pi on 6.
5 pi on 6.
Yeah, it's pi... Here, there.
Yeah.
Pi on 6 in all of these places. So let's go. Pi on 6, then it's pi plus another pi on 6. It's not... Oh, no, sorry. It's this one. It's 1 short. It's 1/6 short of pi. Then it's 1/6... Yep, further than pi. And then it's 1/6 short of 2 pi. Do you get that? Because 2 pi all the way round minus pi on 6 minus 1/6. 2 minus the 6th is 1 5/6, which is 11 pi on 6. Or you can think of 2 pi as 12 pi on 6. So pi on 6, 5 pi on 6, 7 pi on 6, 11 pi on 6. All right? Now, the other way of doing it, did anyone try dividing by cos squared x? I'm going to. So 3 sine squared x equals cos squared x. Often when you see sine and cos, actually more for sine and cos, but cos squared, 1 minus sine squared is good. But let's say I did divide both sides by cos squared x. They would cancel. Do you see why I want to divide by 3 as well? Yeah. I'm going to divide by 3 as well. Sine squared x on cos squared x is tan squared x is what? A third. So therefore, tan of x is plus or minus 1 on root 3. And what's all 4 quadrants? I think we should get the same answer. All 4 quadrants, what's your acute angle? Yeah, and there you go. Same answer. Same answer. Acute angle pi on 6, same answer. So you could have done that 2 ways. All right? Often if you see a sine and a cos, sine equals cos, it's often changing it into tan by dividing both sides by cos. I didn't have to divide by the 3 straight away. I could have moved the 3 later. But I thought divide it now because you just want tan, not 3 tan squared x. All right? Now we're going to try another one. Question, can I move down a bit or not? F. Can I move? So then you would get the same now from here. All right? Question F. The question is tan squared x plus tan x equals root 3 tan x plus root 3. Okay, we've got tan squared x plus tan x equals root 3 tan x plus 3. Looks like it's going to be a quadratic of some sort. When there are 4 terms, we've got 2 options. Well, we don't really have 4 terms because tan x is really the one type of term. I don't know. I don't think. You might be able to factorise this in pairs. I'm not sure. Maybe you can. Can we factorise in pairs? Yeah, why don't we try that? Look, there are 2 options here, girls. If we decide to combine these 2, you would end up with 1 minus root 3 in brackets tan x. You'd end up with a quadratic equation that's not easy to find the roots of, and we're going to have to use the quadratic formula. That's one way. The other way that might work here, because you've got 4 terms, is grouping in pairs. Factorising in pairs. That is going to be way easier than using the quadratic formula on this. All right? So what have we got? Tan x bracket tan x plus 1. Remember the idea of grouping in pairs is that the second bracket must be identical, otherwise you don't bother. Tan x plus 1. What can I put out the front there to make it the last 2 terms, to give me the last 2 terms? Minus root 3, and does it work? We are lucky. So therefore we've got tan x minus root 3, lovely. Tan x, I would do it this way. You can go, do not go and factorise the left, factorise the right. We never do that. Whenever we're dealing with equations, we take everything to the left, put it equal to 0 and solve. If you put this on the other side, what's going to happen is that, and you divide by tan x plus 1, you're going to lose a whole solution. That's what will happen. And not only that, you're actually going to end up, the other solution will be incorrect as well. So don't do that. So now we've got, therefore, tan x, what have we got? Equals?
Root 3 or negative 1.
Equals root 3, or tan x equals negative 1. So we're quadrants what and quadrants? Tan x is root 3 is quadrants 1 and 3, and quadrants 2 and 4. All right, acute angle x, tan of what is root 3? Tan of? Yeah, it's tan of 60, which is pi on 3. Draw in your quadrants 1 and 3. And quadrants 2 and 4, what's your acute angle? Yeah, acute angle is 45, which is pi on 4 in quadrants 2 and 4. Now, if you've got it drawn visually, it's just a very quick sketch, but it'll hopefully make sure that you don't make mistakes. So therefore, x is, for the pi on 3 one, what do you get? Pi on 3 and?
4 pi.
Yeah, a pi plus another pi on 3. It's 1 1/3, which is 4 pi on 3. And the other one, acute angle x, is, so x here is what? Well, there's pi, and you're stopping 1/4 short. 3/4 pi. Remember, this is 0, half pi, 1 pi, 1 1/2, 2 pi. We're going 2 pi short how much?
7 pi.
Yeah, it's 7 pi and 4 because it's 2 minus quarter. See, 2 pi all the way round. Okay, and that's that one. So we're looking at questions like question 19. Not going to do those exact questions, just going to change them. So first example I'll do is solve. So we're solving between negative pi and pi. Solve the following. Let's do cos of 2x equals a half. We're solving this. Okay. Oh, this one's not too bad, actually. All right, what do you do? Well, we've got to change the domain because this is for x. So 2x, if that's the domain for x, what's the domain for 2x? That's right. No, it's not. It's doubling. To go from x to 2x, I'm doubling. This is 2 times around the circle, like 2 of, times that by 2, times this by 2, times that by 2. In other words, yeah, we're going twice around the circle. I don't know if you can see that very well. I've got negative 2 pi is less than or equal to 2x, which is less than or equal to 2 pi. And yes, we're going twice around the circle, but we're not doing it, we're not going twice around like you think. We're going from 0 to 2 pi and we're stopping, and then to do the second loop of the circle, we're going backwards because we're going from 0 to negative 2 pi. See what I'm doing? Yeah, I know I've got 2 loops of the circle from this, but you're going from, because from negative 2 pi to 2 pi, there's 0 in between. So you go 0, you do all 4 quadrants, you have to go that way one way, and then the second round is negative angles I want. I want all the positive, all the negative angles. Okay, so, all right, cos is positive in quadrants, what? 1 and 4. Acute angle, not acute angle 2x, sorry, not acute angle x. Cos of what is a half, girls?
2x.
Yeah, cos of 60. So the 2x is 60. See, cos of that is a half. The 2x must be 60, which is pi on 3. Okay, that's the acute angle. Don't go and tell me that x now is pi on 6, because it's not. Well, it will be for one of the solutions, but not. It's not how you do it. So acute angle 2x is pi on 3. So what do we do now, girls? I draw in my quadrants. So therefore 2x is what? Give me my solutions. pi on 3. No, just do this way first. Let's go from 0. Yeah, that's 2 pi. 2 pi minus a third. 2 minus a third. 2 minus a third is 2 2/3. Because look, that's 2 pi all the way round. It's 2 minus 1/3. So it's 5 pi on 3. They're my positive angles. Let's go negative angles. So now this way around. Negative pi on 3. Negative 5 pi on 3. Now we divide by 2. Not earlier. Now do we divide by 2. Because why do you think we're going twice around the circle? Because we're working with 2x. So we're going around the circle like that. Gives me from 0 to 2 pi. And from 0 to negative 2 pi is going around the circle backwards. So basically, you've got the same results. Well, one's positive, one's negative. So therefore, x is, what do you do now? Divide by 2. Minus pi on 6, minus 5 pi on 6. Okay, another example here, question 19 type. Solve sine of 3x is negative 1. For negative pi through to pi, we've got to change our domain. What do we have here? That's right. And where is negative 3 pi and 3 pi? Let's have a look. We've got 0, pi, 2 pi. So 0 to 2 pi, that would be 3 pi. 1.5 times round. Pi, 2 pi, 3 pi. Got it? And then the other way. Pi, 2 pi, 3 pi. So you do end up going around the circle 3 times, but you do 1.5 in one direction and 1.5 in the other direction. 1.5 and 1.5 makes 3 circles. All right? So, all right, what do I do? Remember, there's only 3 steps. First step, your quadrants, acute angle. Actually, forget the acute angles here. I'm doing sine is negative 1. So you may not actually do it this way because it's sine of something's negative 1. Well, I'm going to sketch the sine curve. No, not with this type. I'm just going to sketch the curve. Look. Watch. Isn't that the sine curve? Where am I up to so far? 2 pi. And then that's pi. Isn't this 3 pi? So let's just sketch it. This is the easier way to do it. Oh, don't sort of fit. But then I've got minus pi, minus 2 pi. Over there, squished is minus 3 pi. Oh, what a mess. I'll do it again. All right, we go again. So we've got pi, 2 pi, 3 pi, negative pi, negative 2 pi, negative 3 pi. Okay, where does sine of, why do you think I did that? Why do you think I'm going from 3 pi to negative 3 pi? Just wait. Remember the new domains from negative 3 pi to 3 pi? That's why I'm drawing from negative 3 pi to 3 pi. So what have I got? So therefore, 3x is, I'm not going to write acute angle is. 3x is, well, negative 1 is here, there. There's negative 1, and there's negative 1. You've got to tell me what those values are. Yeah, it's between 1 pi and 2 pi, which is 3 pi and 2. It's between 0 and negative pi, which is, in other words, it's between 0 and negative 1, which is negative a half, which is negative pi on 2. And it's between negative 2 and negative 3, which is negative 2.5, which is negative 5 pi on 2. That's what 3x is. Therefore, x is 3 pi on 6, negative pi on 6, negative 5 pi on 6. And you can write your 3 pi on 6 as pi on 2. Negative pi on 6, negative 5 pi on 6. And if you want to check them all out, go to your calculator and if you do put them in anyway, sine of 3 pi and 2 is sine 270. That's negative 1. Sine of negative pi and 2, yeah, you can see them at work. So girls, remembering for sine x, cos x, if they're equal to 1, 0 or negative 1, we just sketch. Got it? All right.